Dear students, in this video we are going to talk about the definition, that is complete graph. Okay, complete graph. Then we will see about cycles and wheel in a graph. Okay, so the complete graph, the definition goes like this: the complete graph on n vertices denoted by kn. So wherever you find a complete graph, it is denoted by kn. So it is a complete graph having n vertices. So what is this? This is a simple graph that contains exactly one edge between each pair of distinct vertices. Okay, so exactly one edge between each pair of distinct vertices. And one more point is that it is a simple graph. Simple graph means you will find only one edge between two distinct vertices. There are no presence of two edges, right? Suppose there are two vertices A and B, so there should be only one single edge between A and B. There should not be presence of any others edge. Okay, so that will be called as multigraph. But in simple graph, only one edge is present. So exactly one edge between each pair of distinct vertices. Now this each pair is very important. So we will see the difference between complete graph and non-complete graph later. So first of all, go with the definition of and examples of complete graph. Now there are four graphs here: graph 1, graph 2, graph 3 and graph 4. Okay, so let's talk about graph 2. There are two edges, that is this one, two vertices, and two vertices are connected with single edge. Okay, so there is only one edge connecting to two vertices, so that's why it is a complete graph. There is no any edge remaining which is to be connected, right? Now graph number 3, there are three vertices, so each of these vertices pair is being connected by the edges. Okay, there is no pair remaining here which is yet to be connected, right? Now third one is that there are four vertices, that is v1, v2, v3 and v4. So you will find that each pair of vertices has been connected by edge. So this graph is called as complete graph. Every pair of vertices is connected by the edges. Okay, now let's take the example. For example, take the example of graph number 3. So in graph number 3, suppose there is one more node. Okay, yeah, here one more node is present. So and suppose this is being connected with this one like this. But this graph is not a complete graph because each distinct pair of vertices is not connected. Means suppose if you number the vertices here in this graph, so let's say this is A, this is B, and let's say this is C, and this newly drawn it is D. So you will find here there is no edge between A to D. A to D there is no edge. Okay, so it violates the definition that each pair of distinct vertices should have an edge. So this will not be called as complete graph. Now come to the graph number 1, that is only single node. So even though it is having single vertex, it is called as complete graph. What definition says that there should be each pair should have one edge. Okay, but there is no any pair here, so that's why it is called as complete graph. Okay, so only single vertex graph is a complete graph, right? So keep in mind that single vertex graph is also called as complete graph. Okay, next is cycles. So in graph you will find cycles. So definition of cycle is that cycle Cn where n is greater than 3, at least 3 vertices are needed. Greater than or equal to 3 is a graph that consists of a single cycle. Okay, so at least 3 vertices are connected in a closed chain, we call it as a cycle. So this will form a cycle. Cycle means from one node you are coming to the same node. If you are starting from this vertex, you follow this path and you are coming again to this vertex, so it is a cycle. Okay, so if you start from here in this graph, you will follow this path and you are coming to the again the same vertex, that is forming a cycle. Now why here at least 3 nodes are needed? If you start with 2 vertices, vertex A and vertex B. So if you start from A, you will reach to B, but from B you cannot again go to the A, because that will be repetition of this edge. Okay, so cycle, it will not form cycle. From A you are going to B. From B, here there is no any cycle. So for cycle you should at least have 3 vertices. Okay, so that is called a cycle in a graph. Okay, now next is wheel. So wheels is what? When for a cycle, when we add additional vertex to the cycle graph for n should be greater than or equal to 3, and connect this new vertex to the each of these n vertices of graph, then new edge will be forming and we call it as a wheel. So as we know that here in this figure of how many edges? 3 edges, 3 vertices. So if you add one more node here or one more vertex here and connect this with every other edge, this will form a wheel. Okay, so for every cycle graph where n is greater than 3, if you add one more vertex and connect this vertex with all other vertices, then it forming a wheel. Okay, so if you understood these definitions, that complete graph, then cycles and wheels. Thank you all.